All right, I'm going to do all the multiple choice in one video, so it won't really follow the pages, but I don't know the page numbers anyway, as we saw in the last unit's videos, so we're going to do multiple choice. All right, so all the following images can be formed by a converging lens. So a converging lens is that kind of fatty in the middle lens there where the light's going to come together. So parallel light gets sent through the focus, the center, and they can kind of come together over there. So which ones cannot? Well, virtual upright larger. This is a magnifying glass. Magnifying glass, so that works. Virtual and upright, and then larger. Real, inverted, and smaller. That's the eye or a camera. So that definitely can be made. Real, inverted, larger. That's a projector. Real, upright, larger. Ooh, there it is, right? First off, I don't know what to call that. Secondly, you cannot have real and upright. They don't go together. They do not equal each other, so you can never have real and upright. So that's going to be our key answer there for D. Concave lenses cause parallel light rays to hit the lens and to do what? Well, I don't know. I don't know what a concave lens is. We got to think about that. Oh, concave. That means caves inwards, skinny in the middle there. And so that's also known as a diverging lens because it makes the light, as it hits it, diverge away, not to a focal point, but it does come together at that kind of virtual or negative focal point back there. Again, remember that number is negative when we get to the numbers. All right, convex lens, ooh, that's fatty in the middle. Convex lens causes it to converge. So those light rays are going to come together. Oh, I need to answer the previous one. Well, we'll answer them together. So that converges to a focal point there, positive focal point, and so we call it a converging lens. So 2B for diverging, 3A for converging. Right? Let's see. How are the focal length and center of curvature related? We didn't talk a lot about this, just because it's just kind of twice the focal length. It does create some different images. The 2F or the C, right? You can see it here, focal length C or 2F. That does kind of tell you where you should place your object to create different images. So if you're inside the focal length, that's going to be a magnifying glass. If you put your object here, that's going to kind of create a projector. And if you put your object outside the center of curvature or 2F, this is where you get the eye geometry. But we didn't talk that much about that actual location. We just looked at the results to predict that stuff. But the focal length and center of curvature are half of each other. So the focal length is half, or the center of curvature is twice the focal length there, D. But not that important with knowing the name of that thing. Just knowing about the images produced is. All right. So if they're in here with this picture, if I place an object here in the front, right here, it's going to be inside the focal length. So this is our magnifying glass area. Just as a review, that's magnifying glass, projector if the image is there, and that's a camera or eye if the object is out there. I said image, I meant object. Where you place the object. And then the image will form on the other side, or virtual if it's placed there. But this particular one is your magnifying glass. So that is going to be a virtual, upright, and larger. So virtual, upright, and M greater than 1, right there, E. All right. What about if I place that object way out there, right? Placing the object way out there is how our eye works and how a camera works. So this way out here is kind of a camera or an eye, and it's going to produce a very small image kind of right in here, right? We're going to get a much smaller image there, and you could draw it out. You could kind of sketch it and say, oh, what's going to happen here? Oh, I should be using my straight line feature. And then that's going to go through the focal point. All right, I would have gotten it right if I had done that. Oh, boom, there it is. It wasn't a bad prediction. Right there, right? So it's going to be smaller. And so that's that idea. So it's real, inverted, and the magnification is smaller. So there we go, A, right there. And then 7, the object is placed in front of the converging lens at a distance of 1.5 the focal length. What does that mean? So in front of the lens, that's over here, 1.5. So we've got the object 1.5. I know that one's tough where it is, but it's in here right there. So that is going to give us a projector, and so that is going to be greater than right there. All right. So lens in a human eye is what type of lens? Concave or convex? And therefore the image on the retina is what? So only two options it possibly could be. I take that back. It could be a couple of different, but it is a concave lens, so it's either A or B. And since it's acting like a camera, it's going to be inverted. A. The image on our retina there is upside down on the retina because it and your brain actually flips it over the other way. All right, and then last two, which of the following is not additive primary color of light? So which one doesn't, not a primary color for it? And that would be yellow. I know that's tricky, but when it comes to light, yellow is the secondary color. Green is the primary because that's the cones that we have. So we have R, G, B as our different colors there. Number 10, dispersion is caused because. So remember, dispersion is that splitting apart. So we're going to go in, we're going to go across. Red is going to stay up here a little bit, but then our kind of blue light, or let's just do purple. Purple is going to spread out more, and we get all the different colors in there. So that's the dispersion. It happens because of the frequency of light. So light with a higher frequency refracts more than light with a lower frequency. That sounds pretty good there. Hey, higher frequency refracts more than light with a lower. All right, and that is the multiple choice. Next video, we'll go over the short answer. I think I can do that all in one video.